This is a neat looking place. What do you do here?
Well, I'm a laser physicist. That's a scientist who studies and makes different kinds of lasers and uses them to hit different objects.
Lasers, like in Star Wars?
Well, sort of like that. So anyway, what can I help you with today?
We were using mirrors this morning and noticed a light bounced around the room. We want to know more about how light bounces.
Well, I'd be happy to answer that for you, Bianca. Light that bounces off a surface is called reflective light. The type of surface determines the kind of reflection you get.
A mirror is really shiny. Does that make a difference?
It makes a big difference. If the surface is shiny, then the image you see looks just like the object.
So a surface that is not shiny and smooth will scatter light?
That's right. You catch on really fast.
Does light only reflect?
No, light also refracts.
What does refracted mean?
Well, Bianca, I think it's easiest to show you. Okay, Bianca, we need to put on some gloves and goggles because we're going to work with some liquid nitrogen.
We use these in science.
Good. It helps to be safe when you're doing experiments.
What's that stuff bubbling?
It's liquid nitrogen. We're going to use the vapor to explore reflection and refraction. So Bianca, this is a laser and I'm going to shine it on the gelatin. But first I need to have you dim the lights. What I'm going to do now is shine it on the gelatin. Look closely and tell me what you see.
I see the light coming off into the gelatin. That must be reflection.
Right.
But the light is also being bent. Why is that?
Well, when light travels from one medium, such as air, to another medium, such as gelatin, its speed changes. And when the speed changes, the light bends, and we call that light refraction.
Does the speed of light speed up or slow down when it's going through the gelatin?
Well, because the gelatin is thicker than air, it slows down.
I wonder if magicians create some of their magic with mirrors.
This is a concave mirror. It curves inwards, and you can see that your image, if I hold it in one way, is upright, and then as I get closer, it gets inverted. It turns upside down.
That'd be an easy way to stand on your head.
It really would. This is a convex lens. You can see that the surface curves outwards, and as you look at it, you look much smaller. And another place that uses lenses and mirrors is NASA. NASA needs mirrors and lenses for their big telescopes. Space telescopes like the Hubble telescope, or the Mars Global Surveyor, or the GOES weather satellites.